Hey, it's Camilescu and welcome again to Mixers Inside. I'm very excited to introduce you a new series called Talks, and this will be about talking with experts. The idea for the first talk came from the fact that I wanted to make an episode about phono preamps, but first I started to wonder how to measure them properly. To measure phono preamps properly, taking into account some details, you need a test record. And I want to say a big thank you to Unitra company for providing me a test record. And I want to thank also all the subscribers for making such collabs possible and also for making this channel legit enough to invite knowledgeable experts. So our first expert is a vinyl record cutting expert, and the reason I wanted to invite him is that I started to wonder what are the limitations of the vinyl medium itself. I wanted to separate, when measuring phonopreamps, I wanted to separate artifacts that come from the medium from artifacts that come from the phonopreamp alone. Our today's guest is Andreas Wagner. He's an author of Perfect Groove software. This software allows you to simulate what will happen when you cut certain signals to a lacquer. So this requires a lot of knowledge about vinyl medium. Andreas is also collabing, and this is his recent work. He's collabing with a modern cutting lathe manufacturer called Silito. So hello Andreas, I'm really happy to have you here. Thank you for accepting my invitation, and please tell us something more about you.
Yeah, thank you for having me here. It's really a pleasure. Going back maybe a bit more in time, I'm an expert in signal processing, audio signal processing, and I spent a lot of time in room acoustic consulting. So I've been a room acoustic consultant for theaters, opera houses, and big things like this for almost 10 years. But then I wanted to do more software development again, and bits and bytes I was missing. And this is when I started to start programming again, audio software. And by coincidence and chance, I got drawn into this lathe manufacturing and vinyl record business. And as you said, I started out by writing a software called Perfect Groove for a project which was called HD Vinyl, which was the idea to totally abandon all the old 100-year-old technology of how to create a record and introduce a very new idea of creating a record. And it failed in the end, but it taught me a lot about what's going on in vinyl recording and how lathe works and all the intricate details of a groove, which was very interesting. And now I call myself an expert, or people call me an expert, some do.
Yeah.
And on this way, I bumped into James Silito, as you said, from Australia, and he started building his own cutting lathe, a modern version of the good old cutting lathe. So the old technology, or the whole idea how to create a groove, is the same as the Neumann lathes from 50 years ago, just with modern technology and modern components. And when the HD Vinyl project stopped, or was stopped due to we just couldn't do it, I started writing a new software which now does the same as Perfect Groove did, which is take the audio and create a virtual groove from it, and then analyze the groove, so predict what's actually going to happen on the disc. And with James Silito, we put it one step further, so the software not only analyzes the audio and prepares the cut, but it also actually does the cut, so it sends the audio and all the control signals to the lathe in the end.
Okay.
Yeah,
So
that's
as I
about me.
understand, the whole principle of this lathe you are working on is very similar to Neumann. You also use a stylus for cutting and the big platter and stuff, but it's somehow improved, right?
Well, yes, it's the concept has not really changed very much from, if you look at a VMS 80, which was almost the last lathe model that Neumann put out there in the 80s, and which was already very advanced. And what James is doing and what other lathe manufacturers are doing is to do the same principle, but with more modern components. And some have a different approach. And the Silito machine is very similar in terms of it has a platter, it's rotating, it has
Yeah.
a heated stylus, it's cutting into the same lacquer material that you use for a Neumann. It's even using the same cutting stylus to cut into the lacquer as you would put on a Neumann. It's just having, or James has built his own cutting head, so that's new. That's the most important thing I would say about a lathe. And the motor is a very new motor model and very high-end motor, because you want a very controlled rotation per minute. And so it's using modern components, and in the end it's using my software to predict the cut and make this a bit more easy or quicker to use. Because with a Neumann machine, or in the old days, to check if your cut actually would fit on disk, which is maybe something we'll touch on in a bit, you would have to do a dry run, which takes you real time. So you would
Yeah,
wait to
exactly.
20 minutes until you know, oh no, it won't fit. So you have to redo it again. And these are the modernizations we try to implement to make it a bit more streamlined, the whole process. And as you said, figure out issues way before they actually happen.
Yes, yes. So this is just this opportunity to simulate it is just a game changer. Yeah. Instead of trial and errors in like real life, you can somehow predict what will happen. And
Yes,
also, it's very important to mention and that the Silito lathe and other as you mentioned, because there are some other lathe manufacturers. It's
sure.
really exciting topic because. There like since like last 10 years there the new manufacturers appeared, but for the long time pressing plants struggled with lack of machines. Yeah, and all you could get all the gear you could get to actually start to make vinyl, to press vinyl and to cut vinyl was like vintage and was second hand, right?
Yes, I mean, this is what happened in the 80s when the CD started to rise, and the whole industry was shifting away from vinyl and shifting into the CD manufacturing. People just threw out the lathes. They were put in a parking lot and destroyed or sold or put on a scrapyard, and really big, really expensive, really high-end engineered machines, but they just threw it away and everybody flocked onto the new CD business.
Yeah.
And if not for some, I would say, vinyl enthusiasts in the 90s, mainly in the electronic and DJing scene, they saved this format. They saved some of these machines. And then when the vinyl picked up again and became interesting again, people were looking on scrapyards for these old Neumann machines. And you're totally right. If you, even today, the high-end cutting business is happening on these old 40, 50-year-old machines. I mean, the last Neumann was built in mid-80s. So yeah, that puts it in almost 40 years yeah, it's about 40 years old now. And it's very expensive to get such a vintage machine.
Yeah, yeah.
And but they are vintage, as you said, and they don't become better over time.
Yes, yes. So first of all, they were like produced in a limited amount, and you must really search for it.
Yeah.
And also, as you mentioned the machines, Neumann machines, are already like 40 or 50 years old, and they are also aging. Yeah. So we are somehow in need to make new machines to because they can't run forever, right?
No, they can't. And for example, the VMS 80, which is the last, the most famous machine maybe that Neumann built in limited quantities. As you said, I think there's 40 or 70 models around. I don't never know the numbers, but it has digital components in it. So the pitch computer is actually a computer. It's an 8-bit computer from the
Okay.
80s. And if one of these chips dies or multiple of these chips dies, you have a problem replacing them
Yeah,
because they're
yeah.
just not available anymore. And like with any old electronic, capacitors die, and rust takes over of some, I don't know, PCB boards, and it's electronic and electronic ages, and it doesn't really age well. Yeah.
Yeah. I see. By the way, ending this topic, I want to talk about some funny anecdote because I heard that pressing facilities or more like cutting facilities were angry about Asian audiophiles buying Neumann machines to playback vinyl instead of turntable. They just bought it to store it at home as a main turntable to get premium quality. So
Yeah.
they were like blocking the ability to cut vinyl just to run some records. Yeah.
Yeah,
Uh,
can imagine. Yeah.
yeah. So we talked about this silly toe machine. It's very nice because it's somehow reviving the process of cutting vinyl and make it possible to further continue. And now it will be great to talk about the vinyl medium itself. And this is also where your software can show a lot of things. We must be aware that vinyl medium has many limitations. And we must be aware that vinyl medium and all analog mediums are different from digital, and not all kinds of signals can be cut into vinyl the way they are. They must be processed to like fit the norms and like satisfy the needs of the medium. So I want to ask you, what are those limitations of this medium? What are the artifacts where like what can possibly happen when you cut it in the wrong way, and what compromises must be taken into consideration when you cut the grooves of the record, and how the signal must be processed to like fit in.
That's a lot of questions. Yeah, you have to stop me if I talk too long.
So
So
maybe let's start from beginning. Yeah. So limitations. What kind of limitations vinyl medium brings?
I think that the most basic limitation that people sometimes forget is it's only two channels. It's only stereo. So there was a quadraphonic era in the 70s, but in your groove you can't do Dolby Atmos or something crazy like this. So it's good old stereo. I would put this as one limitation.
Yes.
Then I often hear that you can't be as loud as a digital file, which is somewhat true. You can cut a very, very loud record, but it comes with some disadvantages. And I think the most of everything you have to take into consideration as a cutting engineer is bound to volume or gain. So how loud do you really want to cut? Because what happens if you cut louder? So the groove is wiggling left to right. It's becoming wider and narrower, and the more volume you put into the groove, so the louder you make the groove, the more it begins to move. So if you have a mono signal or a very mono-centered signal, it moves more from left to right. And if you have a stereo signal, it becomes more wide and more narrow. And you can do all this to a certain amount until you hit some issues. And the first issue is there's a limitation for you. Space on the side of the record is limited. So a digital audio file you can more or less record endless, but on a record you have to fit your groove onto this 10 to 12 centimeters of space, and this is limited by this limits your volume. So if you cut louder, as I said, it starts wiggling more. It just requires more space on disk. So if you cut louder, you can't fit your 22 minutes onto one side, but it will get down to maybe 19 or something. And this is also, if you pay someone to cut your record, they usually have a fixed fee until 20 minutes, and everything above 20 minutes costs extra because it's more difficult to fit it onto the disk. So volume versus run length, that's one limitation. And then if you cut louder, the needle has to still move in the groove on playback. And if the groove is moving too much or too fast, the needle becomes too fast, and it just might get thrown out of the groove. So it just may lose tracking. This is the very worst case. So if you cut too loud, your needle will just be kicked out of the groove and will skip. And before this happens, it will distort. So if the needle begins not to be able to trace the groove anymore because it's too loud or too quick, then you will hear distortion in your audio. So what you want the compromise in cutting is always a compromise between cut it as loud as possible because of another limitation we'll get to, which is dynamics. Cut it as loud as possible, but cut it only so loud that it doesn't distort, let alone skips. And the louder you cut, the less you can fit on disc. So you always have this triangle of quality, runtime, and gain or volume, which you have to navigate in cutting.
Yeah, but you told that cutting loud grooves is problematic, and there is like obvious solution. Why not cut quieter grooves? But we also must mention another story, yeah, because when you cut more silent grooves, you are actually closer to noise, right?
Yes. You have to imagine that the wiggling or the movement of the groove, which I described, is very, very small. So at a 0 dB level, so not maximum, but very high reference level, you have the groove moves a couple of 10 micrometer left to right or something. It's really, really not very much. And if you lower the volume, so the quieter the cut gets, the less is the movement. And at some point, if you look at the groove, you cannot see anything anymore, but there's still a little bit of movement in the groove, which is translated into audio. But at some point, you have the surface noise. So you have the surface of your pressed record, which isn't perfect, which is the lower limit of what you can actually cut. Below this, you can't cut any audio signal because it just gets lost in the surface noise. And I don't think it's so bad as the reputation is of the record. Especially most modern music doesn't have a very, very high dynamic range. So
exactly.
Most stuff is pretty terribly mastered to death, so to say. The loudness wars from the 90s.
Like the dynamic range is small, it's compressed, yeah? And
it is compressed.
It's squeezed, yeah?
Yes. So where you need a very high signal to noise ratio is, for example, for let's say a classical music album where you have a difference between a soprano singing at piano or a single violin playing very quietly. You still want to hear this, but you also have to fit the full tutti of the orchestra onto the disc. And this level difference, that's what's called dynamic range. And this is a bit limited in vinyl compared to digital format. So just an example, CD, our classical digital format with 16-bit, gives us dynamic range of 96 dB. So if you have 0 dB, you can reproduce minus 96 dB level, which is already a very, very high dynamic range. If you do a cut on a lacquer disc, you have about the same dynamic range as a CD in the studio, in the cutting studio. So if you do your lacquer cut on your cutting lathe with your heated stylus and it's really, really smooth, then you have about the same 100 dBs, approximately 100 dB of dynamic range. But then it goes into the production process, and then between the cutting room and your finished product in the store, you lose about 30 to 40 dB. So dynamic.
So you lose 30 dB when you start to press records?
Well, that's difficult to say who's to blame, because depending on who you ask, they will blame each other in the whole manufacturing chain. But somewhere between the cutting studio and the pressing, you lose some signal to noise ratio, or you add a noise floor in the medium. I think part of is in the PVC medium, part of
Yeah.
is from the
Because
pressing.
you mentioned that when you cut the lacquer, you can
Yeah.
actually achieve a very similar dynamic range to CD, like
Yes.
about 90 dB. But there is also something that is called a dub plate. And
Yeah.
this is a disc that is actually made of PVC, right? It's a plastic thing. Or
Usually it's, I'm not sure if it's PVC, but it is a plastic. It's PETG or something, some other
and
plastic.
is
Yeah.
it possible to cut the dub plate that will be ready to playback with also such huge dynamic range, or you are already losing something because of using plastic, not some more refined material?
Yeah, I have to say I don't know because I'm not, I have never cut plastic. I'm not a plastic expert, but I think it's good enough, or yeah, it's good enough for
Okay,
clubs
okay.
and things. I don't know. Actually, I don't know the signal to noise ratio of plastic. Would be interesting to know in your comments.
Yes, yes, for sure.
But I think it is less dynamic range achievable than with a lacquer
Yeah, but
master.
anyway, in a more standard production process, when you actually press the records, you lose a lot of dynamics, right?
Yes, in the end, you have something like 60, 50, 60, 70 dB of dynamic range, which is still traceable on the pressed, on the finished product. And then if you have, then people talk about how different colors sound different because some different color, the tiny fragments of the particles of the color increase the noise level as well. So some people believe that black vinyl sounds is the smoothest. I don't know.
Yeah, it's also a controversial topic, and I heard a lot of different opinions on this.
But I can
Yeah.
tell you for sure that if you have a picture disc, which is quite popular nowadays, so you have between the two sides you have a laminate of a picture, so you can actually see the picture when playing, and you can do funny stuff. But this actually creates a higher noise level.
Okay. Due to material used and like a surface,
Yes,
yeah, an
yes, yeah.
uneven surface that it's
It's
generating the
just
noise.
more grainy surface, and you can hear the surface noise compared to a black vinyl.
Yeah,
Yes.
sure, sure. Okay, so we already mentioned those limitations in dynamic range. We said that it's quite difficult to cut loud grooves, but at the same time we must remember to like keep this compromise to be far away from noise. But you mentioned, and it's very interesting, that modern music doesn't have really high dynamic range, so the noise is an issue, but it's not something we should really worry about. More problematic is like this limitation from above, right? Like
Yes.
actually cutting the louder groove, it generates more artifacts and distortion. And so we covered the let's say amplitude domain, yeah. But we can also talk about vinyl limitation in frequency domain.
Yes.
We must be aware that the bandwidth of vinyl is limited, and I'm really curious about what's the bandwidth limitation, what are actual numbers, how like how wide can be how wide signal can be pressed. And I already noticed, because I got a like not test pressing, sorry, I got a test record that allows me to test the gear, and there are some frequency sweeps, and I noticed that when there are two versions, till 15 kilohertz and till 20 kilohertz, and I noticed that when you want to press high bandwidth signal and when you want to press 20 kilohertz, you must actually go down with the volume. You must limit your bandwidth to achieve some reasonable level, right?
Correct. Yeah. There's, I think that the biggest reason for this is that you could probably play it back. If you cut a very loud sine tone, or your sweep, if you cut it louder, you could probably play it back on your record player. The record player wouldn't explode, it would be fine. But the first problem that you face is on the cutting side of things, because the coils in the cutter head don't like high volume, high frequency. So the higher the frequency, the higher the velocity of the cutting stylus becomes, and the higher the current that's going through the cutting head's coils becomes. And if the current becomes too high, these coils just run hot and in the end burn. And then you have a cutter head with a burned coil, and that's a very expensive thing to experience, or at least takes you out of business for a week or two until you have these coils replaced, unless you can replace them yourself. Advertisement for the Silito head, it has user replaceable coils. Usually you have a fuse which blows before this happens, but this is something to protect your cutter head. So if you would cut a sweep from 20 to 15 kilohertz and from 20 to 20 kilohertz, as you discovered, the 20 to 20 has to be a bit lower in volume, because of the fact you want to protect your lathe from overheating or from burning a coil.
So in short words, like cutting high frequencies louder means problems, mainly in the cutting process, right?
Means stress for the cutting engineer, stress for the coils, so stress for the machine and the person doing it, because the person has to worry about the machine, and the machine, shouldn't be damaged by the music. So this is one limitation, but this limitation is the interesting thing for some cutting engineers, especially if you look at drum and bass cutting engineers cutting +9 NAB level or +12 insanely loud electronic music, which is really, really full of high frequencies and really is stressing the medium. But I think they're riding, or they're seeking the thrill of actually making this possible. So if you have a cutting engineer you have a good connection to, and you want to experiment with him or her, try it out. But usually people try to limit the high frequencies and not to run into issues during cutting.
And one question that came to my mind right now, because from the economic perspective, is it possible that when you actually turn down the high frequencies and you cut lower amount of higher frequencies, your coil in the head will live longer?
Well, ideally, you should never push the coil to a point where it's stressed over time and fatigues, so it's really getting weaker. Usually you want to keep it in the range where everything's acceptable. But yes, you could probably or potentially prolong your head life or your cutting head life by not cutting extreme things. Yeah.
Okay, I see. Okay, so we talked about limitations, and now maybe it will be nice to talk about solutions to those problems. Yes?
One very important limitation we haven't talked about, also before we recorded, we haven't talked about it, is something that everybody knows about vinyl, is you have to reduce your bass. And so
that's why I wanted to also ask about the solution, because RIA curve, I don't know if everyone is aware of this, but the signal on vinyl record is not pressed or is not cut. I'm confusing cutting and pressing, but first we cut the lacquer, and so the signal that is that becomes cut doesn't have flat frequency response. It goes through the RIA equalization, which solves at least two problems. One of this problem is, as you mentioned, we must take down the bass level, And why is that?
Well, the bass I was about to talk about is a different issue, but let's talk about the RIAA curve first. That's very important. What you have to, so if for everybody, I think your main people of your audience know what a DAW is and are experienced in looking at the waveform maybe. So if you look at the waveform of an audio signal, it goes up, it goes down, and this is what you would expect that is cut on the record, which is not true, because the waveform is the amplitude, but what is cut on the disc is not the amplitude, but the velocity, which, fast forward, means that if you would not apply an RIAA curve and you would just cut your sine tone or your sine sweep with constant level, it would have a very, very large excursion for low frequencies and a very, very tiny excursion for high frequencies. Same. It is very similar to your speaker. If you watch your speaker cone move with the bass, it's a lot of movement, it's a lot of excursion, and the tweeter for the high frequencies doesn't move at all. So to overcome this issue, because again, very, very strong excursion for low frequencies would cost you a lot of space on disk. So what the RAAA curve does is it lowers the level of the bass by 20 dB and it raises the level of the high frequencies by 20 dB at approximately 20 kilohertz. So you can, it's not a line, it's more an S curve between -20 for 20 hertz and +20 for 20 kilohertz. And this way, it sort of equalizes how much space each frequency takes up on disk. And this is one story of the bass. And then on playback, of course, you have to do the same, just inverted. So your phono stage is not just an amplifier, but it applies the inverse of this RAAA curve. So it boosts high frequencies. Did I say it right? No, it lowers.
Yes, during playback, it actually boosts the bass and lowers the highs. Yeah,
exactly. It boosts the bass by 20 dB and it lowers the highs by 20 dB. So this is what's happening in the RAAA curve. But the other thing I wanted to mention real quick is if you have, as I said, a mono signal, it's moving left to right all the time with a constant width of the groove. But if you have a stereo signal, especially for bass signal, the groove becomes wider and narrow and wider and narrow. And if you have a very strong stereo bass, maybe a strong bass reflection from the room, an echo, which is stereo or out of phase, then your groove will do this, and then at some point it might become too skinny for the needle to trace, and then the needle will be kicked out again. So this is the bass control that people ask for in mastering for vinyl cutting, that you cannot have stereo bass. You can have normal bass as much as you want, but strong stereo bass will face an issue or will create an issue for cutting.
I see. Okay, so we can say that RIA curve solves some of the problem, and maybe is it right to say that it also somehow, like thanks to the RIA curve, do we overcome in some level surface noise? Because when high frequencies are boosted on vinyl, it means that this content is louder, so it's far away from the surface noise, right?
Yes, correct. Yeah. As I said, with the speaker, as you say, your tweeter hardly doesn't move at all. And the same, if you would cut without the RIA curve, the excursion, the movement of the high frequencies would be very, very low. So they would easier drown in the surface noise. So boosting these by 20 dB and then bringing it down back later makes sense and overcomes this bad signal to noise ratio or worse signal to noise ratio for high frequencies. Yeah.
Okay, right. So also in context, because you said that we basically, when we cut vinyl, we deal with velocity, velocity of the how to say it, like needle
of the needle or stylus.
Or stylus, yeah, right. So the fact that there is some velocity means that the stylus can't achieve infinite velocity. Yeah, to press the stuff on vinyl, we must somehow limit this velocity, because otherwise it will cause some issues. So first thing is can we mention something about this velocity limiting? But in this context, I would like to ask you, and I'm not sure if I'm not confusing two different issues, but is in this context of like velocity, 45 RPM pressings, does 45 RPM cutting helps with such issues? And what can 45 RPM cuts bring positive to the process?
Okay, so there's another issue which we haven't talked about. So for high frequencies, if you put the higher the frequency on disk is, the smaller the wavelength becomes on disk. So if you say it goes left and right, for 1 kilohertz it goes left and right. For 10 kilohertz is very, very quick. So the geometric shape that the needle has to trace, or the stylus has to trace, and it has to go into all the crooks and corners, is becoming smaller and smaller for high frequencies. So this means at some point your wavelength on the disc is actually smaller than the radius of your needle. So we're talking about 8 micrometer radius for an elliptical needle. So micrometer, that's 1 millionth, is it, of a meter. So it's really, really tiny. But this is it is happening on the disc, and this means that some higher frequencies just cannot be traced anymore by the stylus, because the stylus compared to the wavelength on disk is just too big. So there's a natural roll-off of high frequencies depending on your cartridge and on your stylus shape. So for example, if you have a DJ stylus, which usually has a spherical 36 micrometer diameter or radius stylus, this just can't get into all the high frequency parts of the groove. Now, if you cut the same thing at 45 RPM, your wavelength gets stretched a little bit. It's by factor 1.35, which is 45 divided by 33 1/3. So all the wavelength, all the groove gets stretched a little bit by 35% wider, which means that your needle can suddenly trace more high frequencies, because the high frequencies get stretched a little bit more and you have more chance of tracing the high frequencies. So yes, cutting at 45, you're again, downside is you lose space, because you need more space on disk because it's rotating quicker. But if you do a single release 10-inch EP or something which has 1 or 2 songs on the side, you can easily do it at 45 and take the gain of higher frequency tracing, and you don't really care if you lose 20% of disk space.
Okay. To sum up this topic, I think it's very important to mention that when we press music on vinyl and when we cut the lacquers, we must be aware that the rise times will be controlled, and they can't be very steep, right?
Yes.
They must be more smooth in order to properly track the record. Yeah.
There's a limit of what's possible, and this is usually done with either a velocity limiter, so dynamic processing, or with a simple EQ where you just shelve off the high frequencies, everything above 18 kilohertz or whatever. Yeah.
So I'm not sure if I'm thinking about it the right way, but I come to the conclusion that maybe this is also one of the things that makes vinyl sound different. That when we deal with lower rise times, it means that they are not really sharp, so it can sound more smooth. Yeah.
Yeah, I agree. I mean, there's many factors of what's different between record or vinyl sound and digital sound. But one thing that people dislike about digital, or usually say that they don't like about the digital sound, is that the digital is so harsh and crisp and too brutal to their ears, and the vinyl sound is more compelling and more soft. And I think, a little bit of roll off of high frequencies, which corresponds to your rise time explanation, is one of the reasons why vinyl sounds warmer or more pleasing to the ear. Yeah, some ears.
Okay. I hope that for the viewers, the things we're talking about are quite clear. But let's not forget that we can use your wonderful software to visualize some of those things. Yeah. And I'm really curious about simulating some test signals, or maybe simulating some signals that are to be cut on the lacquer. Maybe we can just watch some of those things. I will be very curious to maybe view some boundary conditions, where when we are starting to mess around with the limitations, how the signals can look like when we take too much of something.
Yeah, so I'm sharing my screen. I hope you can see it. Hope the viewers can see it as well. So what
Yes.
I did a compilation of a very boring test disk, I would say. So we
Okay.
start with a very, very boring signal, which is so boring that it just shows up as one block up here. So that's a sine tone 1 kilohertz on the left channel only, followed by sine tone 1 kilohertz right channel only. Then we have a mono signal, stereo signal, and then some more interesting stuff. So let's have a look at what the groove looks at 1 kilohertz
And
sine tone
can
on
you
the
please
left.
explain what do we see like under those blocks
Oh yeah,
to test
sorry.
signals?
Sorry, yes. So this is this is the waveform, and below this is this is the space-time control software. I should start with this. This is the control software and analysis software, which I wrote for the Silito lathe. And what it does, it creates this virtual groove, which you see here on the right in the microscope.
So this is just a simulation. What will happen when we cut those signals into the
Exactly. Yeah.
lacquer?
Exactly. And what we're looking through the microscope on the top of the groove. So I prepared some images and doesn't show up. No, it shows up. So
Okay. Wow.
this is not my image. Stole it from internet, but I'm not the only one to steal it. This is, I think, an electron microscope rendering. So it's not in real time of what it would actually look like if you trace a groove on disk with a stylus. And so this is what it looks like, and this is very highly magnified. So you have your needle sitting in this groove, and this groove has this V shape, 90-degree V shape, and you have one modulation of the wall is the right channel, and the modulation of the other wall is the left channel. And if we would actually look through a real microscope, it looks something like this. So this is similar to what we saw. This is a left channel only, so we have only this side is modulating and the other side of the groove is not modulating. So this is pretty straight, and the right side is what's changing. And this is what we actually see here in my microscope simulation. You see that here it's a left channel, so the left wall is moving, and you have to imagine the V shape, but the V shape doesn't really have much information, so I'm only projecting the downwards view from top. But this is what a 1 kilohertz tone looks like. And now we spoke about volume. So if we increase the volume, you'll see what's happening. So you see that it's becoming more pronounced. So the belly of the groove is becoming more pronounced. And same if we have a right channel only signal. And if we move to the mono signal, you see what I mentioned before, the wiggling. So it goes left, right, left, right, left, right. And if we increase gain even more, it's using up more space on disk by becoming wider.
So this is mono signal where left and right channel are just the same, right?
Exactly. This is in phase. So this is it's the most boring signal on earth. It's a 1 kilohertz tone, same in the left and the right channel. Let's make it a bit more interesting. Let's put it out of phase. So this is what I mentioned before with the bass out of phase. So now left and right channel still have a 1 kilohertz signal, but their phase is opposite. So when the left channel is up, the right channel is down. And this is what it looks like on disk. You get this, it's opening and closing, opening and closing. And if you exaggerate it and make this too terrible, then you have a problem on disk and you can't cut this anymore.
Because the needle can't track two of those signals at the same time, right?
No, it can, but you can imagine that the needle is not moving left and right anymore. The needle is moving up and moving down, moving up, moving down, because it's becoming narrow, it's becoming wide. And there is a certain limit of how narrow a groove can become, because if it becomes too narrow, your needle is just jumping out of the groove and is gone, and you have a skip. And there's a limit of how deep or how wide you can actually cut, because at some point you will cut through the lacquer surface and you will cut into the aluminum and of the master disc, and that's a problem. And you get a problem in the pressing when a groove becomes too wide, because then the the PVC doesn't want to get out of the stamper and effects like this. So there is a certain limit of what variation in width and depth a groove may do before you have a problem.
And can I ask one more question regarding this out of phase signal? Because
absolutely.
I'm really curious. Can we somehow simulate what will happen when we press low frequencies and what will happen when we press high frequencies? Because right now we are seeing 1 kilohertz, right?
Yes.
And till now we said that the biggest problem with phasing is for low frequencies, right?
Yes,
they must be in phase.
They should be, yeah.
Should be.
So let's jump ahead, and this crazy signal is now a bit more interesting, because this is what you had on your test record. This is a sweep signal, and it starts at 20 hertz and it goes up to 20 kilohertz, where even my simulation, my graphics has some issues to display it correctly. But as you can see, it's moving very slow down here, and it takes a lot of more space than the high frequencies. So the high frequencies are this, and they take up less space because they almost move in one line, and the 20 hertz move left and right. So this is again sine sweep but mono. And if we move on to the next one, here you see it. This is your sine sweep in stereo.
Okay.
So here it becomes the difference in very wide, very narrow is much, much higher than for higher frequencies. And this is why strong out of phase bass may be a problem, because what the software or what the cutting controller is already doing here is it's controlling for depth, and we can see this here. So I didn't answer your question before. So what we see down here below the waveform is some analysis parameters. So this is disc level, and we can see, let's drop it back to -9 where we were. So all my sine tones come in at 0 dB NAB reference disc level.
Okay.
And also I cut the sweep at the same reference level. And we can also look at stylus velocity, and this is what we've spoken before. So here you can see that this is our sweep. These are both sweeps. That's the mono sweep, and this is the out of phase sweep. And you can see that with exponentially rising frequency, our velocity is rising exponentially as well. And this is going off the chart. So this is something that will definitely, at this level, destroy your cutter head, blow a fuse at least.
So that's why we actually must keep the high frequencies in, like not very loud.
Exactly.
To make it possible to cut.
Exactly. Yeah. This is why we would have to drop the level for the sweep, because we just can't cut it at this level. And
is the sweep cut with rear curve applied?
Yes. Yeah.
And
it is.
Can we somehow see how it affects the groove?
Oh, we can disable the rear curve, and then crazy things will happen. So this is...
Oh, yeah, okay. So the groove is really wide now for low frequencies, right?
Yeah, it is. Let me measure this. This would be 1.2 millimeter. So this is nothing you can ever cut. This is insane. And you can see the same for the sweep here. Without the RAAA curve, it just takes up so much more space. Let me... switch it on again, and we can see how it changes. So this is what the RAAA curve, it really compresses our excursion, lateral excursion here and vertical excursion there.
So as I can imagine, the groove without rear curve is so large that even the stylus doesn't have space to move this wide, yeah?
Yes, and probably, I mean, the width, this would definitely cut into the aluminum already very long. So you would have broken your stylus if you would have tried to cut this without the RAAA curve. What I wanted to say, because here everything looks still fine and we don't really see an issue except that everything is very, very wide. But what we already see is that the depth correction is already kicking in. So the software or the layout module already increases the width of the groove, because otherwise we would have passages where the groove becomes too skinny due to our out of phase base. Let me disable the auto width real quick and then we'll see what I mean. So here, this is what we would have cut, and here we would have, you see the black stripe, there's nothing there. So
the
if
needle
we would
like jumps, yeah?
Yeah, it would, the cutter head would lift off, it wouldn't cut into the lacquer anymore, and then it would come down again and cut very deep into the lacquer. And let's see where we're maximum at. Yeah, we see it here, we're above 150, which is, I would say, the limit that we want to do. And yeah, here we are at 122. That's already quite a lot. So out of phase base is an issue because it creates excessively wide grooves, and even with width control, which usually helps to control some of this, it's not possible to cut this. And talking about solutions, one very, very popular solution among cutting engineers and less popular among artists is an elliptic EQ or elliptic filter. And what this does, it removes bass below, so it applies a low cut, high pass at a corner frequency, which you can select, and then it removes this bass from the side signal. So it keeps all the mono information, but it removes stereo bass. So let's be brave and put it to 200, and then you can see that all this out of phase bass goes away, but then it's gone. So it's better to keep it in the mastering in the center, or center it a bit more, because
not to
otherwise
deal with it afterwards. Yeah, it's good to keep it in mind when just producing music. Yeah,
I think this is one of the most important things that people have to keep in mind when mastering for vinyl, is that you can't have very wide stereo image bass, because your cutting engineer will A, not cut it, or B, will just apply an elliptic filter. This is a bit crazy what I did. So let's bring it down a bit. Yeah, that should be fine. But you can see that this is almost gone. So the information here for the low frequencies is very, very much diminished. Yeah, so make your bass mono if you want to cut on vinyl. That's my recommendation. But this was just boring test signal. Let's have a look at some music, and I'll explain you some more about dynamics. So what I have next here is Paul Desmond Take 5. This is a jazz piece. So this, you can see the level is changing a little bit.
Yes.
There's some dynamics going on, and now this is very quiet. I've normalized all the files to a peak level of -3 dBFS. So all the files have the same peak level, but as you can see, they don't have the same loudness. So this has a very high dynamic, the jazz piece, and usually we would aim at +6 disc levels. Let's bring it up a bit more, and then even a bit more. And then we can see that the groove, there's something, it's moving a little bit, but it's not moving excessively. And you can also see where the quiet parts are, because the quiet parts don't require as much excursion. So the quiet parts are closer together, and you can see this here. And if we look at the velocity, so this is what we've been talking about velocity a lot. Let's only look at the velocity of our jazz piece. And there is no strict number of you have to cut or stay below 30 centimeters per second or something. There is no fixed number. It's experience. And I just try to show what's going on in the groove here. And we show a full bandwidth velocity and a low and mid band velocity. So you have to make yourself an educated guess if this is a problem or isn't it. I don't think it's a problem. So this is exceeding 30s sometimes, but usually staying around 20 or below 20. So I think this is totally something you could cut fine on lacquer.
Is your software somehow showing some warnings, like be careful, this can be tricky?
This is something I did for Perfect Groove, and I didn't do it here. So Perfect Groove threw a lot of warnings, but the problem with a lot of warnings, usually you just ignore them after a while. So I'm at the moment, I'm not trying to put out any warnings unless you're really clipping the digital audio. That's a hard no. You can't do this. But otherwise, I'm just trying to explain in the manual and by teaching people what to look for and what is an absolute limit. So for example, 150 would be an absolute limit. So this would not be possible to cut here, but the rest is probably fine. And yeah, this is for all the parameters that you can look at, where you have to build up knowledge and learn about what's possible and what might be an issue.
This is a tool for like people with some experience that are actually knowing something what's going on. Yeah, it will not shout at you and tell you like bad, good. You must feel it, right?
Yes, yeah. You have to understand what you're looking at, and especially it doesn't automate anything. So there's no magic wand button where it fixes all your problems. It just illustrates your problems and leaves it to you to fix them on your own. And let me jump ahead I have two more tracks, which I probably can't play because then you have issues with YouTube. But this is Verdi Nabucco. So this is a orchestra piece. And then this is really, really high dynamic. This is what I mean by dynamic content. So here you have a lot of going on. And then you come to the passage where it's only one singer, very, very quiet. And the groove almost doesn't move anymore. I'm not sure if you can see it on YouTube on the video, but you can see it here on my screen. It's wiggling a little bit, but there's just not much information. And this is why it's very important to cut at a good level, because otherwise, if you cut it very low, this passage will probably drown in the surface noise.
Yes.
Yeah. And now to a bit more modern and crazy groove. So this is Igor. I'm not sure if you're familiar with the band. I would call it avant-garde, techno metal, whatever. I don't know.
No.
But it's very loud. It's very, you can see that it doesn't have very high dynamics except for this passage. So it's this level all the way through, and it's really loud. And you can see, this is very interesting, I think, you can see electronic music in the groove, because these really, really sharp onsets here, these very, very short transients, that's something you hardly ever find in acoustic
organic
music.
Acoustic music.
This is very, very electronic and crazy things like this. And let's have a look. And here the velocity is going through the roof. It's very high velocity, so you probably might have issues cutting this on the cutting side of things. You will probably have a distortion on playback, maybe.
So what's the cause of this high velocity here? Lack of dynamic range and like squeeze audio, or
it's just the very, very, so the blue color you see here is an indicator for the velocity. So the brighter the blue gets, the higher the velocity is. You can see that the high velocity parts are always look very crunched, and this crunched is a very high frequency, strong high frequency content. So there's a lot of electronic beats and hi-hats and strongly distorted signal in there, which is causing these high frequencies. So if you would roll off the high frequencies here a little bit, you would probably lose a little bit of fun in the music, but it would be possible to cut it. And actually, I do have a cut, and let's see, we are at +6, and I have a cut of this album on LP, and it is cut even louder than this. So shout out to whoever cut this. This was amazing work, because this is really, really riding the limits of what's possible to cut on vinyl, and it sounds great. Yeah.
Okay, cool. There is really a huge difference between modern stuff and older recordings, as well as you said, acoustic music and electronic, yeah? Because
Yes.
in electronic music, you can actually generate all kinds of signals that don't appear in real life, yeah?
Yeah.
And this is clearly visible here, this difference.
And maybe last thing that we spoke before. Let me remove some of the things. Sorry, that's not very entertaining. And let's try to put this on a smaller disc. See if it fits on a 7-inch. It does fit on a 7-inch. Okay. So now what we have our test signals, and we have the Igor as a spacer, so to say, and then we have a sine tone at the very inner diameter of a 7-inch record. Oh, we have to increase. Let's keep it at 33 for now.
Mm-hmm.
So now we have a 7-inch record which has a very small diameter in the center. And if we compare, let's zoom in a bit. If we compare what our 1 kilohertz tone looks like here at the very center of the record compared to the beginning of the record, you can see, I'm not sure if you can really see it, but
I'm not seeing it right now. You must
okay,
explain.
yeah, it's not, it is a bit difficult to notice, but switching back and forth, I'll switch back and forth a bit. So, well, let's count. We see 1, 2, 3, 4, 5, 6, 6 wavelength at the outer diameter, and we see 1, 2. Let's put this away. 1, 2, 3, 4, 5, 6, 7 and a bit at the inner diameter, meaning that it's getting crunched up towards the center. So towards the center of the disc, your wavelength is becoming smaller. And now if we increase our cutting speed to 45, we have a problem because we exceed our disc capacity, of course. So let's remove some more. Let's try again. Yes. So now it's a bit difficult to see, but what happens is that it's getting stretched, so that the distance between this peak and this peak and this peak becomes wider by changing the cutting speed to 33.
So thanks to this, we can achieve
45.
We can achieve wider bandwidth closer to the center of the disc, right?
Exactly. And this is exactly why the 7-inch is popularly with 45 RPM, because at 33 RPM, with a very small disc diameter, you lose more high frequencies than at 45. So if you have a single which only contains 1 or 2 songs anyway, you would speed it up to 45, so you retain your high frequencies at very small diameters. Yes.
Okay, great. It was really good explanation. I hope that it will clear some things out, because on the first part of our talk, we're like talking and showing things with hands, and now I hope it became much more clearer.
I mean, if always disclaimer, I might have misspoken, I might have explained something wrong or badly, so I encourage everyone to write it in the comments or get in touch, and we'll do another session to explain all the errors I made.
It's always good to discuss things, yeah. And if somebody has any doubts or wants to present their point of view, we are very open. It will be great to see this. Yeah. So we saw all the imperfections of vinyl. We see that we can't get loud cuts. We, especially with this electronic music, it's becoming a problem with high frequency content. Cutting engineers must like have a big struggle to actually make things gentle, to make it even possible to press, yeah, because as you showed, some material is even impossible to press, right?
Well, as soon as you have cut it, you can probably press it. But cutting,
it's impossible to cut. I'm still confusing this.
Yes,
because to be fully aware, because not everyone knows it. First, we cut the lacquer. It then becomes a stamp, and then to like make more copies, then we just press and
Exactly.
yeah.
Yes.
But the first initial stamp, how it's called, like the mother disc, or never
The
mind.
well,
Like,
the cut.
the stamp.
Well, there's yeah. Let's take the usual process. You have your lacquer cut that's called the master disc, and then from this master disc, you create. Oh man, father. I'm always wrong
Yeah, in
on this.
Polish, it we call it mother disc.
Yeah, first you have the father, then from this you have another copy which is called the mother, and then from the mother you create a stamper, and then this is the negative again, which is pressing the
Yes,
final
exactly,
record.
exactly. So what I wanted to say, you can essentially press everything you want, but you can't
Yes,
cut everything you want.
correct.
Yeah,
Yeah.
it can even damage your lathe. Yeah.
Yeah, and
So
depending on your lathe, there's a lot of lathes out there which have helium cooling for, so they actively cool the coils with helium so they don't overheat, so they can cut even more louder stuff.
okay, okay,
Yeah.
okay. Yeah, so taking all this stuff into account, like those amplitude limitations, velocity, noise floor, because vinyl has quite high noise floor due to surface noise. I wonder if should we really care about quality of phono preamplifiers, because as we know, and you already mentioned this, the record is being cut, then it's read, and to get the proper frequency response, we must pass it to the phono preamplifier, which not only boosts the amplitude but also applies this RIA correction. So essentially, I wonder if quality of this block of phono preamplifier really matters, and should we really care about signal to noise ratio and stuff like this when vinyl as a medium is already imperfect. And I wonder if some standard analog solutions are just fine, or you must be really careful about picking a right phono preamplifier.
Well, I have to be very careful what I say about this probably because there's lots of opinions out there, and I would say you should care about each part in your reproduction chain. So you should care about the turntable, you should care about the cartridge, you should care about the preamplifier, you should care about the amplifier, your box, your speakers, your room. As a room acoustician, I can tell you that all the listening rooms I see on high-end media on Instagram are terrible.
Yeah, are not treated sometimes even. Yeah,
Not
they
at
have
all,
just
not at
bare
all.
walls, and
There's a
you really hear a lot of reflections. Yeah.
there's a 2 million euro stereo system sitting in a very bad room, and I could cringe. But anyway, I think it all matters, and it all adds a little bit of to the experience. And the biggest concern with a phono preamp in my mind is that what comes out of the cartridge is such a very small signal that you have to amplify it and boost it quite strongly. I think a phono preamp, I'm not sure, so disclaimer, not 100% sure, but I think it boosts at least 40 dB.
Yes,
And
for 1
that's
kilohertz, the most usual boost is 40 dB for 1 kilohertz, but for the bass, as we mentioned, which requires to be even more boosted, it's 60 dB.
okay. So 60 dB is factor of 1000. So which means that your miniature tiny signal is amplified 1,000 times and magnified 1,000 times at 60 dB, and 40 dB is still something like 200 or something. So this is a lot of amplification. And if you have a noisy preamp stage, you will add noise to your very small signal and then amplify this noise again. And that's something. So you need a very clean, strong phono preamp to boost this tiny signal without adding noise or creating distortion in the signal. So I think signal to noise ratio of the preamp is important, and the THD, total harmonic distortion of the amplifier, is important as well, unless you want something tube based where the point of using an analog tube is actually adding distortion to the signal because it sounds more pleasing. So again, either you want it very clean, so you want low noise floor and high signal to noise ratio, and low THD, or you want something warm and nice sounding, and then it's high THD and you get a different signal, and that's your personal preference.
Yes, but it's also worth to mention because you said that we should care about every part of the signal chain, and I must completely agree that when we deal with really sensitive small signal from the cartridge, we should care about signal to noise ratio of a phono preamp, but there is also another way to deal with it, and especially we can see it in the DJ world, where we deal with high output cartridges, right? Because I think correct me if I'm wrong, but I think that like a standard high fidelity phono cartridge is something around 1 to 2 millivolts, speaking about moving magnets, something like this. But when we consider DJ cartridges, the amplitude can be like 6 or 10 millivolts. So when we enter the phono preamp, we already have a higher amplitude from the cartridge itself, and this is one of the options to also deal with signal to noise ratio, right?
It helps, yes, but the difference isn't gigantic. So
okay,
it
the
is.
Signal from high output cartridges, the signal from high output cartridge is still tiny, right?
It is still tiny, yes. You still need a lot of amplification. You just don't need as much amplification. So maybe your spec for the phono preamp aren't as tight as for a really, really high-end moving coil or something cartridge, which has a very, very low
moving coil
output.
have even smaller output amplitude, right? And another thing I wanted to ask you in this context of cartridges is because in DJ world the most popular cartridges are spherical with spherical stylus, but there are also options to buy elliptical stylus. And how can it help with sound reproduction? How getting elliptical stylus can enhance the signal?
Well, if you think back of what I just showed and the wiggling, and then you have to imagine that your stylus has to trace every one of these small changes. And as I said before, with a spherical stylus, which has a bigger diameter, you can't trace all the very, very fine edges of the high frequencies. So a spherical stylus usually has a frequency response which rolls off lower than as an elliptical stylus.
Yeah, so you have just higher bandwidth, right? You can
elliptical
reproduce
stylus, yes,
larger amount of high frequencies thanks to elliptical stylus because it tracks the grooves in a more precise way, right?
Yes, it can trace the groove more precisely than a spherical, just because of geometry and because it fits in there. But then usually your spherical stylus has a very strong downforce, so it sits really tight in the groove, which is important for DJs, especially for scratching. It can move forwards and backwards without damaging the groove too much. And I think you could expect a bit more damage to your groove with an elliptical stylus, but that's my speculation.
Okay, sure. So one more question to end the topic of phono preamplifiers, because I'm really happy that you have a very technical approach, and also you are just you dealt in your career with analog signals and also with digital domain, and you know what happens when we convert analog to digital and the opposite. And I would like to ask you one thing: what do you think about this approach? Because there are some mixers on the market from the brand Pioneer that uses a lot of digital signal processing in their gear, and actually I'm trying to understand why, but those digital devices, especially speaking in analog context, in vinyl reproduction context, those digital Pioneer phono preamps and mixers have some bad reputation, and I'm wondering what can go wrong when you actually make your stuff digital and then deal with it in the digital domain? And is it possible also that, for example, mixers that were converting analog to digital that were made, for example, 15 years ago, is it possible that nowadays they are better and it's not any deal anymore?
Well, I think it shouldn't really matter if you apply the RAAA curve, for example, in the digital domain or as an analog filter, because it is a very simple filter. If you can, of course, you can make mistakes between going from analog to digital, and I think over the last, I would call it today in 2025, I would call it a solved problem to get a decent digital signal out of a analog signal for affordable money. I think, yeah, thinking 10, 15 years ago, probably a high quality A to C HD converter chip was maybe, you mentioned Pioneer is a big company, so they think in very big numbers,
Yes.
like German car manufacturers. If a component is €1 more expensive, you can't do this, and everybody thinks like it's €1. Who cares?
Yeah, but it's a scale. Yeah, you
But
multiply it.
and if you think Pioneer maybe, or maybe, I have no idea, maybe they cheaped out and said, oh, this is good enough back then because the higher end option would be much more expensive. I don't know. But I think today it shouldn't be a big issue to find a good, reliable analog to digital chip and then do the digital signal processing afterwards. I mean,
So
yeah,
basically converting analog to digital and then again converting digital to analog nowadays is not a big deal anymore, right? The whole artifacts and stuff are not so pronounced as they used to be, right?
Yes, I think it's not a big deal anymore. Many people think different and may disagree, which is fine. But I look at, I'm working with digital audio all my professional career, and I'm seeing a lot of bad things in music files which come from bad digital conversion or from sampling or for whatever, but people still use samplers from the early 90s to do sampling for hip hop tracks and electronics tracks, and they have crazy artifacts and nobody cares.
Or
It's all
even
fine.
people like those artifacts.
Or people
Because,
like
for
the
example,
artifacts.
there is some Japanese sampler, a very legendary Akai MPC, and actually people are praising the older models that had 12-bit converters because maybe of some artifacts going on, because they maybe make sound more, I don't know, whatever, more crisp or more something.
Well, they at least they add a very, very terrible frequency around 14 to 16 kilohertz, which drove me crazy in my old car because my car stereo pronounced this even more. But yeah, so I think A to D, D to A conversion is today is a solved problem in my eyes, and it's really hard unless you have a Windows PC to find a bad digital to analog converter which sounds bad, and all the rest is fine.
Can you explain a bit more about this Windows, because I'm really curious. Windows PC is it
Just
is it,
in my experience, all the Windows laptops I had to use during my business career always had a very, very bad headphone output. But I'm
okay?
not sure if it was the headphone preamp or if it was the DAC that was bad. But it was just bad. It sounded
Okay. But is
bad.
it possible that the drivers and software were
No,
written incorrectly? No,
no,
it's all
no.
about hardware, right?
That's the chip. Yeah, it was a cheap chip. That's it.
Okay, I see, I see. Okay. So yeah, ending up this whole thing and coming back to some of the first thing we were talking about, I would really love to know in this context of your work with Silito, of this introducing the new modern lathe, uh, are there any perspectives if in the future, or are there already present? Are those already present? Is it possible to improve the cutting process of vinyl records even more? than it was like, years ago when using Neumann stuff?
I mean, yeah, I can mainly speak from the software perspective of things, but this idea of combining software as a preview and analysis tool with then driving the actual hardware, I think will improve, or does already improve. I mean, there's people out there using the software, and I can still sleep fine at the moment. So this process is really taking it to a next level, because what you had to do with a Neumann lathe, or you still have to do today, is what I showed you or what I spoke before about this triangle of gain and how much space you have on the disk, and does it create distortion or not. We are trying to make this more streamlined and more easy to find out, and especially more quick to find out, because with a Neumann machine you have to settle for a level which you think that might work, and then you have to do a dry cut which takes 22 minutes, and after 22 minutes you know, oh no, it didn't fit on the disk, it spilled over by 2%. And this is something that I'm not trying to simulate how it will sound on disk. That's something I don't do at the moment. I've done this with Perfect Groove, but it wasn't really good enough, so I took it out again. But I just want to predict and show what the groove will look like and what the parameters will be. And I think this is a big change of combining the software tool and then the hardware tool, which really brings us forward. And I mean, James is still developing the SDMS, the Silito disk mastering system. It's not, I mean, it is out there in different cutting studios, but it's not like, okay, I'm done with development, I just sell it.
I was about to ask, are there any more challenges you are facing right now?
Oh yeah, a lot. I mean, he's not facing the challenge, but he has taken up the challenge of wanting to cut DMM, which is something we haven't talked about. So DMM, direct metal mastering, where you don't cut into a lacquer disc, but you cut into a copper disc. So that's something which is evolving, and this was in the very last stages of the vinyl format in the 80s. This was invented as a new technology, which has some drawbacks, has some advantages, but this is coming up again as an interesting topic, and James is working on a DMM head to cut direct metal mastering. That's a challenge. We want to automate the lathe even a bit more, so there's still things that need to be improved. On the software side of things, I'm at the moment my pitch algorithm, which is determining how much you can really squeeze onto a record, is something I not copied, not stole, but was inspired by the Neumann pitch control, which they wrote a white paper in the 80s. And I think everybody is just using this algorithm they proposed. And I want to take it further and see if I can improve this algorithm and have my own algorithm, which may be better or quicker or worse, we'll see. And so there's still a lot of stuff that can be brought to light in the future. It's just
not only in the software context, right?
Yeah, software and hardware development. There's
But the biggest and most obvious change and improvement is, as you said, this ability to predict what will happen. Yeah, this is something that really changed the process, right?
And I mean, this is I'm not the only one doing this. So when I started with Perfect Groove, there was another group simultaneously. We were totally unaware of each other, but they at some point came out and it came to my attention. It's called Simulathe. So this is it's a plugin, it's a VST plugin for your DAW, and which does the same what I do. It creates a predictive
digital
model,
cut,
it digital cut, so to say, exactly, and analyzes the groove, and then gives you even some tools to fix some high velocity issues and velocity limiter and the out of phase bass issues and things like this. So I'm not the only one doing the software. There's also other software around, which we all aim at helping the cutting engineer or the mastering engineer before it goes to cutting to improve their music for cutting. Because what is very important for me, because we talked about phono preamps and all that stuff, I usually don't really care about the system. I care more about the music. But what can really ruin a great album is bad sound because someone didn't pay attention to some cutting parameters. And unfortunately, I've seen this in cutting studios where people don't really care or don't understand and just cut, and just make a lot of records one after the other. But you can be sure by just looking at the screen and looking at the parameters of the cut that this won't be a great cut.
I see, yeah. So speaking about cutting lathes, we have like year 2025, but the research is still going on, yeah?
Yeah, it is. I mean, yeah, there's some things I can't really talk about at this point, but there's things in the future which are really interesting. It's just, it is, James often calls it a cottage industry. So it's a very, very small niche. And
Okay, yeah,
I
yeah.
mean, he's on his own developing a hardware lathe, which is amazing. I think when I first saw it, I was like, who, this guy just had the idea at some point, I want to build a lathe. And this is what came out. This is really incredible. And I'm doing some software on my end, but it's just the two of us, researching and developing things.
Yeah.
So on our end, it takes time because there's little funding, and it just takes time until we develop something.
Yeah. I also came up with an idea. Yeah.
But we are not the only ones. I don't want to talk about James and me all the time. There's other people in the industry with new ideas and bringing up stuff. But yeah, that's my story I can tell.
I always I also was about to start a lathe project, and I gave up after a week. I discovered very nice forum. It's called Lathe Trolls, right? And there's a lot of knowledge there. And I succeeded to register there, read some stuff, and then said like, all right, maybe in another life, or maybe like in the future. Yeah, it's really complex topic.
It is really complex stuff, and this is also, I mean, coming back to HD Vinyl Project again, this was just another crazy guy said, oh, I want to revolutionize this, and I have this idea to do it with lasers. But it took us quite a while and quite some, I mean, we had successful prototypes where I have a glass master behind me somewhere, which you can put on a record player, you can play it back, and it sounds okay, it's music. It's just very noisy, and it took us quite some time to figure out that at some point we had to admit that we just can't beat physics, and this industry is difficult to revolutionize because it's already existing for 100 years, and the Neumann company and all the other companies, Scully and all the other lathe manufacturers, have put a lot of research and development money and time and people into this field to achieve the best result we have today. So it's not like nobody thought of this, hey, let's do it now, everything's perfect. It's really small incremental changes, if at all.
I see. Yeah, and you when you're introducing yourself, you said that you used to deal with room acoustics. Now you're writing software, and I want to also ask you about your future plans, and maybe because you are now cooperating with Silito, but maybe you have your own project that you will develop in the future and show to people.
Yeah, I have one small thing which actually I had the idea at some of these vinyl conferences about quality control, because in the pressing plant, quality control is a very big topic, but it's a weirdly handled topic in my eyes because nobody uses modern technology, but just people listen to records. Every 100th record which gets pressed is listened to and skipped through, and this is their quality control process. I was like, why don't you record it in and have a software that analyzes this? And this is something I'm looking into at the moment, to analyze or compare and analyze and compare different pieces of music of the same music. So if you have a recording from this record and a recording from that record, you could chuck it in and it would spill out some numbers and give you the opportunity to A/B listen and compare. And I think A/B listening and comparing directly is something which is highly underrated in this field and highly not used as much as possible.
I noticed that it's just a game changer to have ability to instantly switch the sources because our mind is really tricky. And even when you want to test two devices, and the time it takes to swap the cables already alters your imagination. and yeah, so
Yeah,
this is underrated for sure.
I mean, before I went into room acoustics, I had a background in digital signal processing. So I worked for Fraunhofer Institute during my university time and had a lot of contact with really the pioneers of digital audio. And for MP3 and all the compressed audio formats, they developed a lot of tests, scientific tests, to find the spot where people can't really hear a difference. And this is comparative listening and switching sources and psychoacoustics. And this is really, it's a very broad field and with a lot of knowledge. For example, what you described, there's I forgot the threshold, but there's a time threshold, how long you can really remember an audio
like
signal.
the sound.
Yeah, your impression of this audio. Of course, you can remember I listened to this before, but to really find the nuances, there's a very, very low threshold. I think it's 20 seconds or 2 minutes of how long you can remember. But every time people tell me, oh, I changed this cable in my setup and it changed everything, I was like,
Yeah.
How long did it take you to change the cable?
Exactly. That's also what I experienced, and I have like 100 more questions because it's so fascinating. But our talk is already like 1.5 hours. So
oh wow, okay, yeah, we have to do a part 2 then with the questions
for sure.
from
I
your
will
audience.
be really glad to do this. I have a lot of questions regarding your future project in terms of this A/B comparisons. And yes, I must agree that this is very underrated. Also, the biggest challenge is also to like somehow trick your mind to get rid of all the suggestions, for all the things you think before you listen, because this is also something that it's just our mind, like our brain not only perceives the reality in very cold way, we also treat stuff emotionally, and we are also linked to brands. When we love some brands, we can already think that it's better, but not always it's true. So thank you very much. It was really great talk, and once again, thank you for accepting my invitation. It was great to talk with an expert, and your suggestion to make part 2 is like something I'm really happy about. And I wish you all the best with your projects. You have a lot of work to do. It's super exciting, and I guess see you next time, and fingers crossed.
Thank you.
I hope that you enjoyed this talk as much as I did. I really learned a lot. If you have any other ideas for a talk with an expert, please let me know in the comment section. Thank you very much for watching this, and see you next time.